Okay, so hi guys. I want to apologize for the lack of uploads. We're gonna go ahead and do the following problem. So we have negative 1/2 times we have f of x equals negative 1/2 times the quantity x plus 4 quantity squared plus 2. So we want to go ahead and graph this, and I forgot to, yeah, this is right here. Graph the quadratic function, state the vertex, axis of symmetry, and x and y intercepts. Okay. So for this particular function, and I'm going to try to just kind of fix this here. Okay. We're going to first and foremost state the type of form that we are dealing with here. Now, if you remember from algebra, the vertex form should be it's going to be f of x, or in this case y equals, it can be f of x as well, a times the quantity x minus h quantity squared plus k. So we know that our vertex in this case would be hk. So it would be the following: h comma k. And so so then in our function that we have, I'm just going to rewrite it here. So it was f of x, so it's y equals 1/2 times x. It was x plus 4 squared plus 2. So let's go ahead and kind of label here. We know that it's going to be y equals, and we know that we have 1/2. Now the x plus 4 squared, we can actually rewrite it as x minus negative 4 quantity squared. Okay, that's the way that we would do it if we have a plus in the middle. It's very important to do that in order to do these right, because if we forget to do that and we just, and we just assume that the h is equal to 4, then it's going to be wrong. So we have to remember to do that. So in this case, we would have x minus, and it'd be negative 4, and then quantity squared plus 2, so plus k, which is 2. So in this case, our h value is equal to negative 4, and our k value is equal to 2. Now the axis of symmetry, we want to go ahead and get that out of the way. Is x is equal to negative 4. So, or in this case, h equals negative 4. The axis of symmetry is always x equals h. This is the general rule. General formula for axis of symmetry. Sorry for my handwriting, like always. For axis of symmetry, right? And that's what it is, right? X equals h. And so since we know that our axis of symmetry is x equals negative 4, we know that our vertex is negative 4 comma 2. So obviously, because hk is our vertex here is negative 4 comma 2. So we're going to go ahead and plot that into our graph here. So I'm going to go ahead and kind of just do a different color. So I have negative 4 comma 2 here, and that is considered my vertex, right? So we want to go ahead and make that very clear. Now, and like I said, negative 4 comma 2. And so I know that my axis of symmetry is x equals negative 4. So we're going to go ahead and just draw a vertical, kind of a vertical line that kind of labels or symbolizes our axis of symmetry here, or denotes it on our graph here. And soon enough, the reason why we're actually drawing the axis of symmetry here is so that we can better, and I use AOS for axis of symmetry, so that we can better sketch our graph. So it'd be x equals -4. And now we're going to go ahead and find our y-intercept. So our y-intercept, if you guys don't remember, that is when x equals 0, so it's always at 0, y. So we have y equals -1/2 times x plus 4 squared, and it was plus 2. So when x is equal to 0, we have y equals -1/2 times 0 plus 4 quantity squared plus 2. So this would be y equals -1/2 times 4 squared plus 2, which is 16 over -2 plus 2, which is -8 plus 2, and that's going to be -6. So basically, when our y-intercept, when x equals 0, y is equal to -6. So we're going to go ahead and label that over here. So we're going to just, and let's do this actually. So 0, -6 right here. And let me use a different color. I'm going to use this one. So that is considered our y-intercept right here. Okay. And so now what we want to do is we want to go ahead and try to use 3 other points to the right of the vertex. We already did -4, so the only ones that are left here are -3, -2, and -1. And then we will reflect those points across the axis of symmetry. So really, the way this is going to work is I'm going to use the value of x equals -3. So when x equals -3, and again, I'm going to write my function, -1/2 times x plus 4 squared, and it was plus 2, yes. So when x is equal to -3, f of -3 is -1/2 times, it's going to be -3 plus 4 squared plus 2. Obviously, this is going to be -1/2 times 1 plus 2, which is just going to be, I believe it would be 3/2, which is like, so it's -1/2 plus, I'm sorry guys, hold on, 4/2, which is 3/2. This is approximately 1.5, so you can still put it in there. It'll be about right here. So that's the point -3, 1.5, this black dot here. And then when x is equal to -2, so we're just going to keep going, f of -2 is going to be 1/2, or -1/2, times -2 plus 4 squared plus 2. So again, we're just kind of plugging in our values. And so now we're going to simplify this. -1/2 times -2 plus 4 is 2, then squared plus 2. This equals -1/2 times 4 plus 2, which is -1/2 times, I'm sorry, -2 plus 2, which would be 0. So when x equals -2, we know that y is equal to 0, so it'd be on the x-axis here. And then when it's equal to -1, obviously I do believe it's going to be, let's see here, f of -1. When x equals -1, we would have -1/2 times -1 plus 4 squared plus 2, which is -1/2 times 3 squared plus 2, which is negative 9 halves plus 2, which is negative 4.5 plus 2, which is approximately, I do believe it's negative 2.5. So when x equals negative 1, y equals negative 2.5. So it's like about right here. Actually, I'm sorry. It's actually over here. So this would be at negative 1, comma negative 2.5, excuse me. So now the idea is we want to go ahead and reflect this over, you know, this axis of symmetry that we had here. And like I said, the y-intercept is 0, negative 6, and let me label that there. So, and as you guys can see, this is one of the x-intercepts here. So this would be considered an x-intercept, and it's at negative 2, 0. Now let's go ahead and reflect these points. So I'm going to go 1, 1. So this is 1 point here. So that's how we reflect it over this axis of symmetry. So it'd be like that, and then we would go 1, 2, 1, 2. So it'd be right here. This is our other x-intercept, right? And so that's how we would do that. And then, one second, guys. And then we would do the same thing for this point. Now, this point is a little bit weird, but we can still do it. 1, 2, 3, 1, 2, 3. So it'd be like right here. So then that's where that would be. And it's kind of, it's not drawn to scale exactly, but we can kind of approximate. And then lastly, we would do this point. So it'd go 1, 2, 3, 4, 1, 2, 3, 4. So it'd be like right here. So now the last thing to do, guys, is to draw your smooth curve through these points. And it should kind of look like a hill, if you think about it. It's like a very smooth curve like this. And so this is how you would graph this this quadratic function. And like I said, the vertex, like we said, was negative 4, comma 2, right? And then the axis of symmetry was x equals negative 4, which we labeled in blue, just right here. And then the x-intercepts, I did name one. The other was going to be at negative 6, comma 0. So there's another x-intercept. So let me go ahead and just kind of write everything out. So in conclusion, this is how we would graph this function. And like I said, these are the 4 things that we were asked of this. So again, the x-intercepts are negative 6, comma 0 and negative 2, comma 0. That's where they touch the x-axis. The y-intercept is at 0, negative 6, which is in purple. It touches the y-axis, and then, or crosses the y-axis, excuse me. For x-intercept and y-intercept, they cross the x and y-axis. And then the axis of symmetry is x equals negative 4, which is the dashed blue line here. And then the vertex is at negative 4, comma 2, excuse me. So that is how we graph this function, guys. I do apologize if it was a bit lengthy, but if anybody has any questions whatsoever about these, please let me know. And also, please like, comment, and or subscribe. And thank you so much for watching. And I will see you guys in the next video. Bye, guys.